Chapter 11, our final chapter of the year, where we're talking about circles every day. We're going to start out with tangent lines. So learning target 1, calculate side lengths given a tangent line to a circle. Know that that tangent line is not the same thing as tangent as a trig ratio, opposite over adjacent, so be prepared for that. And then learning target 2, prove the intersecting tangent theorem. Okay, we've got a number of things that we need to do here, and so just some vocabulary. You know what a circle is. It's the locus of points. It's the set of points that is equidistant from a point. And we call that point the center of the circle. You know what the radius is. We talked a lot about that in chapter 10. The radius is the distance from the center of that circle out to the circumference. We'll take care of diameter while we're at it. So the diameter is double the circumference, although we're going to have a maybe more specific way of describing that here in a second. So right now, let's talk about this central angle. Right? The central angle, or acentral angle, okay, we'll call it x. Okay? Central angle is an angle where the vertex is at the center. That makes sense. Okay, so we've got this angle, and the vertex of that angle is right there at the center. That'll be a pretty important thing here in the next lesson. Then chord. What is a chord? Well, a chord is a line segment where the endpoints are on the circumference. Okay? And so when we take a look at the diameter, notice that the diameter is actually just a chord. It's a segment that goes from one part of the circumference to the other. It's just that the diameter is specifically a chord that goes through the center. All right, so we took care of central angle, we took care of chords, and then the last two things here are the secant lines and tangent lines. So a secant line is very similar to a chord, except that instead of being a segment that has a beginning and an end, a secant line, so secant, is a line rather than a line segment. It goes on forever and ever, but it does touch in two spots. And then finally, a tangent line. Well, a tangent line, which is what we're going to be working with today, is similar to a secant line in that it's a line, not a segment, but it touches in only one spot. When you guys get into calculus, you will learn a lot more about tangent lines. Even if you're in physics, you'll learn a lot more about tangent lines. So that's those are the big things, and of course tangent lines is what we're using today. All right, so we've got two big theorems that we're going to use for learning target 1. The first one is the tangent radius theorem. So if I have a circle and then I have the radius here, well, if I have a tangent line that touches in this spot where the radius touches the circumference, so this is a tangent line, call it T, you need to know that those are going to be perpendicular. And if you were in class, then you saw that demonstration on Geometry Sketchpad. So we'll just say, for briefness here, we'll say the radius is perpendicular to the tangent line. And then finally, the tangent theorem. So again, if I have a circle and I have two tangent lines, so it touches in the one spot here, and then we'll make this one touch in this one spot here. Okay, when these two tangent lines intersect, you need to know, if I label this A, B, and C, well, you need to know that AB is congruent to AC. So I'll write that down. AB is congruent to AC. And that, of course, is going to help us set up some equations to write. And, of course, here, this being 90 degrees is going to help us set up some equations. All right. So here's a real classic problem. It says, in the diagram, S, so is a point of tangency. That must be this one right here. Find the radius of circle T. Well, if this is a tangent line and this is a radius, then those meet at 90 degrees. That means that's a right angle. And, well, that means we've got a right triangle. And we can use the Pythagorean theorem to find a missing side. Now you got to be careful. This 36 right here actually applies to this right here. And so on a circle, the radius is going to be the same everywhere. So know that this distance right here would be considered the radius. All right, so as we set up our Pythagorean theorem, we could say r squared plus 48 squared would be equal to, not 36 squared, but 36 plus r squared. So that would be kind of the key difference that we've got here. And so that right there kind of makes things just a little bit awkward for us. We still have the r squared. 48 squared is 2,304. But then as I expand this, in case you've forgotten, this would be 36 plus r times 36 plus r. And here you're going to have to remember a little bit from algebra. Multiplying binomials, you'd have 36 times 36, which is 1,296. And then you'd have 36r plus, now when I distribute this one, another 36r. And then r times r is r squared. Okay? And then over here we've got r squared plus 2304. Now, bad news is, looks like I've got a quadratic because I've got something squared. The good news is, if I subtract r squared from both sides, these actually just cancel out. And so it looked like might be a quadratic because I had the squareds. Well, it turns out it's just a regular thing. So 2,304 is equal to 1,296, and then add these two like terms together and you have 72r. And that's actually just a pretty simple two-step equation. So 2,304 minus the 1,296 is going to be 1,008 equals 72r, and I divide both sides by 72, and I get my radius is equal to 14. So that, it's not a typical Pythagorean theorem problem, but it still has the same elements to it. Okay, here you've got this circle, and it says DA is tangent at A, and DB is tangent at B. Find X. Well, here we just got to remember that when we have two tangent lines that intersect, those two lines are going to be congruent. And so we're going to go ahead and say 25 is equal to 6x minus 8. And of course, this problem can be super simple or super difficult depending on what we want to do with it. So we're going to add 8 to both sides, and that gives us 33 equals 6x. And 33 divided by 6 looks like it's 5.5. Okay. And now on to learning target 2. So here we are proving the tangent-tangent theorem. Right? We need to prove that AC is congruent to AB. Well, here's how we're going to start. We're going to go ahead and draw an auxiliary line, AD. So create, after the given, create AD. Okay, that's our auxiliary line. And you can see that when we've done that, what we've done is we've created two triangles. And if we can prove those two triangles are congruent, CPCTC will give us AC is congruent to AB. So how can I prove these triangles are congruent? Well, first of all, let's realize that with the tangent radius theorem, that this and this are going to be right angles. So I'm going to say angle B and angle C are right angles, and that would be by the tangent radius theorem. Okay? And if I have right angles, that means I have right triangles. And so I'm going to say triangle ACD and triangle ABD are right triangles. And that would be by the definition of right triangle, and that they have right angles in them. Well, now we just need 2 clues to pull this off. And so here's what I'm thinking. We could probably say that AD is congruent to AD by reflexive. And pay attention to what's going on here because remember, the hypotenuse is the side opposite the right angle. Here's our right angle. So AD is the hypotenuse. So let's just maybe make a note of that here. This is the hypotenuse. And then the other thing is, well, we could say that CD is congruent to BD. And that would be because they are radii of the same circle. Okay? If you've got a radius, it's the same as all the other radii on a circle. And, well, that would be a leg. And that is enough to prove that these triangles are congruent. So I'm going to say triangle ACD is congruent to triangle ABD by HL. And now that I've proven that the triangles are congruent, I can say that the corresponding parts are congruent. I can say that AB is congruent to AC by CP All right, and that's it. We're done. Here's what you've got for practice for learning target 1 and 2.